Okay, the electromagnetic spectrum is a family of waves that contain certain properties. Okay, you need to be able to recall the exact order here. The central line there is supposed to be representing a line with different wavelengths, essentially. And the family of waves in the electromagnetic spectrum are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. You need to know that order. You may want to come up with a saying, a mnemonic, say something beginning with R, something beginning with M, something beginning with I, V, U, X, and G. A lot of students that I teach, we watch a video called the Electromagnetic Song, and I'm afraid it has a very memorable chorus that just burns into your brain and you never forget the song. So if you have a chance, look on YouTube, Electromagnetic Song. It will just scar you for life. Right, a couple of things you also need to know is that at one end, radio waves have got low frequency and low energy. So frequency is associated with energy, so low frequency, low energy. At the other end of the electromagnetic spectrum, you've got gamma rays, which have got high frequency and high energy. Notice that in the middle, you've got visible light, and that should say Roy G. Biv. If you notice, I've missed the yellow, the Y for yellow there, but Roy G. Biv stands for red, orange, yellow, green, blue, indigo, violet. Or another way to remember it is Richard of York gave battle in vain. Right then, let's see what the next bit is. Right, you need to know also the size of these things. So they may ask you just to know roughly what the size of these things are. Radio waves have a wavelength of around 1 kilometre. It goes from several tens of meters to kilometres. Infrared is roughly millimetres. Ultraviolet is nanometers, so that's a billionth of a meter, 1/1 million, and picometer is gamma rays. Now picometer is basically 1 times 10 to the power minus 12, so that's 0 point, then you say 11 zeros 1, okay, 0.1101 meters across, a very, very small wavelength indeed. All electromagnetic waves travel at the speed of light. All electromagnetic waves can be absorbed, they can be reflected, they can be diffracted, they can be refracted. If they're absorbed, if each of those electromagnetic waves, so the radio waves, microwaves, gamma rays, all those things, if they're absorbed, it'll create one of two things. It will either heat up the object, or it will create an AC voltage in the object with the same frequency of whatever's been absorbed. And that's the principle of communications, by the way. All mobile phones, television signals all work on that process of absorbing electromagnetic waves and we carry signals on them. You need to learn the order of them, I've said that before, and the wavelength of them. And you can also calculate the frequency of waves by using the wave equation, which is wave speed equals frequency times wavelength. V equals F times that funny symbol is known as lambda. And of course that can be put in a triangle, and hopefully you can work out what V stands for and what F stands for, what lambda stands for. It's underneath now. There we go. V is velocity in meters per second. F is frequency in hertz. Lambda is measured in meters. Right, what do we use the different parts of the electromagnetic spectrum for? Well, radio waves obviously used for communications. I want to share this with you as well, that long waves, in other words those waves with wavelengths of over 100 meters, they're used for sending radio waves long distances because they bounce off the top of the atmosphere, a place called the ionosphere. Shortwave radio, which is sometimes known as VHF, tends to be used for local radio stations. They don't travel so fast, or so far I should say. They travel at the same speed as everything else. They don't travel so far, but they're very good at diffracting around obstacles in houses and streets. So that's why we use VHF in streets, because the wavelength is very similar to window frames, to street sizes, that sort of stuff. So they diffract very well, they spread very well. Microwaves are used for mobile phones and satellite TV. You need to know that. Infrared is used for, is basically a form of heat. You use them in remote controls. So your remote controls at home for your television work on infrared radiation, and also they're used in heat cameras to detect heat signatures. You may see sometimes police programs where they put on a heat camera to detect a bad guy. Sometimes you may play a game of Call of Duty and you wear like infrared night vision cameras, and of course they detect infrared. Visible light is obviously used for cameras, and Richard of York gave battle in vain. It's the colours of the rainbow. Ultraviolet is used on sunbeds, and also it can be used to help prevent forgeries. Most banknotes and concert tickets will have some chemicals in there impregnated or which have a chemical in it that will glow under ultraviolet light. So we use ultraviolet light in fighting crime and forgeries. X-rays, for broken bones and medical uses, and gamma rays are used for sterilization, so medical equipment will have a burst of gamma radiation applied to them to kill any germs on it, so that's what we use gamma rays for. One other thing I need to chuck in here, which is slightly incongruous, in other words, it doesn't seem to fit in here, but it's the only place I can put it in for now, is know that we use infrared for communications through fiber optics. So that black line is supposed to represent a piece of fiber optic cable, a piece of glass that's been stretched out, and if you shine light at one end, it bounces off the inside. Now that is known as, you better remember this, total internal reflection. Total internal reflection, and if you shine in at one end, it comes out the other end, and this is used as a way of sending signals long distances. It's how the internet works, basically, by infrared being passed along cables like this, fiber optic cables. So there you go, that's the electromagnetic spectrum.